Hi, and welcome to this section of the Basic Math Word Problem Tutor, where we're going to continue our study of word problems. And this section we're going to tackle word problems that involve division with decimals, or dividing by decimals. So in this course so far, we've done adding and subtracting and multiplying and dividing whole numbers and problems that deal with that. And we've started to work with decimals and adding and subtracting and multiplying decimals. So here we're just completing things, and we're going to work with problems that end up needing or having you divide two numbers together when those numbers are decimals. So the good news is, if you've gone back and you understand how to do the decimal word, or how to do the division word problems that we had earlier in the class, earlier in a few chapters ago, okay, on the DVD, then you can use exactly the same logic to know when to divide here. It's just that here the division is going to involve decimals, and we're going to practice that here, and we're going to get some really good practice with that. So in general, just to recap, when you have a problem that involves division, it's usually going to involve something that says something to the effect of how much does each thing cost, or you have a total amount of something, okay, and you know that each little part of that is so much. Like you may have a total amount of money, right, and you may have something that costs a few dollars. How many of these things could you buy? So when you have something that's sort of a total amount of something, it could be weight, so many pounds, or so many dollars, or so many cups of lemonade, or something like this, and then you have, and the problem tells you, that each one of these things is so many pounds or so many dollars or whatever. How many could you buy, or how much money would you need, or how many things could you get, or something like this. There's not a great keyword to really focus in on that's going to tell you 100% sure that you need to divide, but I'm trying to give you some tips and pointers that you can use as we go along. But the most important thing, and that I've been talking about in this course all the time, is you must understand the problem. Even if you have to read it 4 or 5 times before you do anything, you must understand the problem. So let's go and do this here, and let's work some examples together. So the first problem says the total cost of 5 DVDs is $55.25, okay? How much does each DVD cost? And this is what I was saying earlier, where you're given a total amount of something. In this case, the total cost of 5 DVDs is $55.25. How much does each DVD cost? That is a dead giveaway for division, because you're given a total amount of money, the $55.25. You know that there's 5 DVDs involved here. So when you're working these problems, you need to start asking yourself, do I need to add these things together, subtract them, multiply them, divide them? What do I need to do? And in this case, you're not supposed to multiply them together, because it's not asking you to add up anything. It's asking you, if you have this much money, okay, and that represents the total cost of all of these DVDs, okay, and you're buying 5 of them, how much does each one cost? So that means you must divide by the number of things you're trying to buy to find out how much each one of them cost, okay? So if we're going to do that, it would look like this. Okay, now what we're going to do then, in order to solve this, is we have our $55.25, and we want to divide into that the 5 DVDs. So what we're doing here is we know the total cost of the DVDs, and we know that we're buying 5 of them. So by dividing them, we'll find out how much each DVD costs, okay? So this is no different concept than any of the other problems we've done in division. It's just that now you have a decimal point in there. So that does make it a little bit different, okay? So the only thing you need to really remember about division with decimals is that when you have a decimal here underneath the division sign, all you need to do is put that decimal point right on top and kind of carry it up, and your final answer, which is going to be up here, is going to have this decimal point in it. So if you see a decimal here, then you put a decimal here. If the decimal's over here, you put it right above. And in this case, we got the decimal point right there, so we're going to put the decimal point right above it, okay? And that's going to be what we're going to do. Okay, so now we just have to start tackling this division. You proceed from this point just as if there were no decimal point at all. You just kind of ignore it, and you'll see as we go along here. So you ask yourself, starting with this first number, how many times can 5 divide into 5? Another way of saying that is 5 times what number gives you 5? Okay, that's what division is. It's the opposite of multiplication. 5 times what gives you 5? Well, I think everybody knows that 5 times 1 gives you 5 exactly. So that's exactly the answer. 5 times 1 gives you 5. Now that you've done that and you write this down here, we're only looking at this digit right now, then you go and multiply and you continue on with your division. So the way you do this is 1 times 5 gives you 5, is what we said, so you write it down and you subtract. Okay? 5 minus 5 gives you 0. Okay, so we subtract what we did here, and now the next thing we do after we do this subtraction is we take the next digit and we drop it down, which is a 5. Okay? Now we haven't touched any of these digits. That's okay. We're going to work our way over. Okay? And then what we do next once we've done this subtraction is we look at this and we say, well, how many times can 5 go into 5 down here? Again, the answer is 1, because 5 times 1 gives you 5. Okay? So now that we've done that, again, we multiply. 1 times 5 gives us 5. And you write it right underneath what you were dividing into here. And again, you do a subtraction. So there's a pattern here. You multiply and subtract. You multiply and subtract. Okay? Now, 0 minus 0 is 0, so we don't need to write it down. 5 minus 5 gives you 0. You really don't need to write that down either, but I go ahead and do it. And now that we've done our subtraction, we take the next spot here, the next number, and we drop it down. And continuing along with the pattern, now we try to divide 5 into 2. Now, let me ask you a question here. How many times can 5 go into 2? In other words, 5 times what will give you 2? Well, the answer is there is no number. 5 can go no times into 2 because 2 is smaller. Okay, so you have 2 pencils here and 5 here. How many times can you divide in here? You can't do it because you only have 2 pencils. You're trying to divide 5 pencils in there. You can't do it. So it goes 0 times. Okay, 5 goes into 2 0 times. It can't even go 1 time because remember, 5 can go into 5 1 time, but now we're trying to go into 2. So you can't even do that. You can only go 0 times. Okay. So we're going to continue along just as if we had done before. Once we put the number up here, then we multiply. 0 times 5 gives you 0. And now you subtract again. Okay? 2 minus 0 gives you 2. And this 0 minus 0 is just a 0, so we leave it alone. Now once we've done the subtraction, we drop down the very next number here in the pipeline, which is a 5. Okay, which is a 5. And now we ask ourselves, now we have 25 written down here. How many times can 5 go into 25? Okay, how many times can 5 go into 25? Another way of saying that is 5 times what gives us 25? Well, from your multiplication tables, 5 times 5 gives us 25. And now that we've written our number up here, we go ahead and multiply and continue on. 5 times 5 gives us 25. And now we subtract, and you get 0 here. 25 minus 25 is 0. So what you've done here is you've finished your division problem, and you have no remainder, which is what happens here when you continue your division and your subtraction and you get nothing. You have no remainder. And that just means that 5 divides into 55.25 exactly an exact number of times, and that is 11.05 times. So the answer is here that each DVD costs, don't forget we're talking about money, $11.05. Okay, so we started out with $55.25. We divided by 5. 5 went into 5 1 time because 5 times 1 is 5. Now we did our multiplication. 5 times 1 is 5, and we subtracted. We got 0, and then we dropped down the next number. Now 5 goes into this 5 1 time, so we wrote it down. Then continuing, 5 times 1 gives us this 5, and again we subtract. So each time we subtract, we write down what the answer was. In this case was 0, and then we drop down the next number. Then we try to divide into that number. 5 goes into 2 0 times because 2 is smaller than 5. So we put a 0, and then again we multiply. 0 times 5 gives us 0, and we subtract. Well, 2 minus 0 gave us 2. And then once we did the subtraction, we dropped down the final number to 25. 5 goes into 25 5 times. And 5 times 5 gives us the 25. We subtract and we get no remainder at all, which just simply means that it divides in exactly 11.05 times. There's nothing left over, okay? So each DVD costs $11.05. Okay, the next problem says 3 people plan to share a bag of gumballs which weighs 11.75 pounds. How many pounds does each person get? So again, this follows the formula that we've been talking about. You have 3 people who are trying to share a bag of gumballs, and the entire bag, is what it says here, the entire bag of gumballs weighs 11.75 pounds. How many pounds does each person get? Usually that's a clue that you need to divide something because you're given the total amount, okay, of something. You're given the total amount, and then after you're given the total amount, you know how many people you're dealing with, and it's asking how much does each person get. So you need to divide 11.75 divided by the 3 people, because that's what you're doing. You're trying to divide that bag up among 3 people. That's exactly what you're doing. That's why you divide, because you're dividing that bag up among 3 people. And when you do that division, you'll find out how many pounds each person gets. Okay, so what we're going to do is, if you just look at what we're doing here, is you have 18.75 pounds, LBS means pounds, and you're dividing it by 3 people. Okay, so if you were going to look at your units that we've been talking about, this bar means division. Okay, that's what this bar means. Anytime you see something on top of something else, it's division. Okay, so 18.75 pounds divided by 3 people. In the end, what you're going to get as a unit is going to be pounds per person, or pounds per person, which is exactly what the problem says. How many pounds does each person get? So when you divide like this, the unit you get makes sense. I'm trying to teach you to use the units to help you figure out what to do. Okay, so if you have your 18.75 and you divide into it your 3 people, how would you begin? Well, the first thing you need to remember is to put this decimal point directly underneath the decimal point in the problem. Okay, that's the first thing you need to do. And then in order to begin dividing, you need to start looking at your digits. How many times can 3 go into 1? Well, 1 is smaller than 3, so it can't go any times at all. It goes 0 times, because 3 times no number at all will give you 1. You just can't do it. Okay? So you could put a 0 up here, but it's really going to be meaningless, because if you put a 0 in the leading digit here, it doesn't make any sense. It's like the number 250. Okay? Well, I can put a 0 in front of here, 0250, and that doesn't mean anything. I can put as many zeros in front of here as I want to. Really, it only matters, the first number is really when it only begins to matter what you're talking about. So you could put a 0 up there. It's just that it doesn't really do anything. It doesn't add any information to the number. Okay, so we just leave it blank. Okay, so then since you can't divide into 1, you begin to look at both digits together. How many times can 3 go into 18? Okay, and you can think about that in reverse. 3 times what number gives you 18? And from your multiplication tables, 3 times 6 gives you 18, and we write it above the 8 like this because we're looking at 18. We're not looking at 1, we're not looking at 8, we're looking at 18, so 6 goes above the 8 like this. And now that we've put our number here, we multiply. 6 times 3 gives us the 18 we just talked about, and we do our subtraction. Well, this becomes 0. 18 minus 18 is 0. Okay? So once we've done that subtraction, we drop the next number down, which is 7. And then we begin to see if we can divide into 7. Well, 3 times what gives you 7? Let me ask you that. Well, there is no number that 3 times something gives you 7, but just thinking about it, 3 times 1 is 3. Okay? 3 times 2 is 6. So we're getting closer to 7. 3 times 3 is 9. That's too many. You're trying to divide into this thing, and you need to find the number that you can divide into without going too far. Okay? So 3 times 2 is 6, so we know that 3 can be divided into 7 at least 2 times. It can't be 3 because 3 times 3 is 9, and that's too big. You're trying to find a number that will fit into 7 without going too big. So 3 times 2 is 6, so we write it down like this and we subtract. Okay? Now we subtract. 7 minus 6 is 1. Okay, now that we've done that subtraction, we drop our 5 down. Okay? And now we have a number here that we're going to try to divide into. 3 divided into 15. How many times? 3 times what gives you 15? 3 times 5 gives you 15, so we'll write it down here. 3 times 5 gives us 15. We subtract and we get 0, which just means that we've completely finished the problem with 0 remainder, no remainder at all. So that means that the answer is that each person gets 6.25 pounds per person of of stuff here, of gumballs. Okay, so that's what we're doing here. We're finding out how many pounds goes to each person. So if a bag has 18.75 pounds of gumballs in it, and 3 people attempt to share the bag, when you do this division, you get 6.25 pounds per person. And we just began to look at the digits. 3 didn't go into 1 at all, so we looked at 18. 3 times 6 gave us 18, so we wrote it down, we subtracted, we dropped the next digit down. Then 3 goes into 7 2 times, because 3 times 2 is 6. That's pretty close without going over. 3 times 2 gave us 6. We subtracted, got the 1, and dropped the 5 down for 15. 3 times 5 gives us 15 exactly, so we put this down and we had no remainder at all. So we stop and the problem is over, and you have 6.25 pounds of gumballs per person. Okay, the next problem says you plan to split one pie 4 ways. How much of a pie does each person get? Okay, so this is the same kind of thing. You're told that you have one pie, so that's how much of something you have. You're splitting it 4 ways, so there's 4 people involved, and you're trying to find out how much person does each person get. So when you have a problem like that where it says how much of something does each person get, or each of something gets, usually you're going to have to divide, and it just makes sense. You cut this pie in 4 pieces, you are dividing the pie up. You want to see how much pie goes to each person. So what you're going to do, math-wise, is you have one pie and you're dividing 4 people into it. Okay, so that's what you're going to do, and you know, just when you just think about it here, the number 1 is really 1.00. Okay, you know, you can write any number like this. Remember, 25 is the same thing as 25.0. The same as 25.00 is the same as 25.00000. You can put as many zeros as you want after this decimal point. It doesn't matter. It's the same number. 1.00 is exactly the same as 1. It's just those decimal points, those zeros after the decimal point, really don't add anything to the number. Okay, so we're just going to write it down like this, and you'll see why in a second. So we're going to put our decimal point above exactly as we have done for all of the other problems, and now we are beginning to divide, ready to divide 4 into this one whole pie here and see what we get. So 4, how many times does it go into 1? Well, it goes 0 times because 1 is too small. It's actually smaller than the 4 that you have, so it can go 0 times. Okay, 0 times 4 gives you 0, and then subtracting 1 minus 0 gives you 1. So all we did was we said 4 can go into 1 0 times, and then we multiply to get the 0, and we subtract. It's just the standard thing we do. And then the next thing we do after the subtraction is we drop down the next digit. Okay, now how many times does 4 go into 10? Well, 4 times 1 is 4, and 4 times 2 is 8, and 4 times 3 is 12. Well, that's too many. 4 times 3 gives us 12. We know that that's too many times because we only have 10 here. So 4 times 2 is as close as we can get to 10 without going over. So now that we put the 2 up here, 4 times 2 gives us 8, and we subtract. Now 10 minus 8 gives you 2. Okay, 10 minus 8 gives you 2. So we do this subtraction, and then we drop down our next digit here, which is a 0. Okay, and now we look and we say, well, how many times can 4 go into 20? And how many times is that? 4 times what gives us 20? Well, from your multiplication tables, 4 times 5 is 20. So we do the multiplication. 4 times 5 is 20, and we subtract. 20 minus 20 gives us a fat 0, so we're done. We stop at this point. And then what this tells you is, in decimal form, each person gets 0.25 of the pie. Okay, and if you were to go and look at that and play around with that, that would be 1/4 of the pie. So it kind of makes sense that each person gets 1/4 of the pie because you cut it up into 4 pieces, and that's what 1/4 is. It's 1/4 of a pie. Okay, so you've used your division to work through it to find out that each person gets 0.25 of that pie, and you knew you had to divide because you were given the total amount of pie, which is 1 pie, and you were dividing it among 4 people, so you're dividing. Okay. Now the next problem is kind of interesting, and basically it says that a train travels at 34 miles per hour, so that's its speed. It goes at 34 miles per hour. How many hours does it take to go 110.5 miles, okay? So we know a train is going 34 miles per hour, and we know that it's going to go 110.5 miles, and the question is, how many hours does it take to do that? Okay, so you can look at this two ways. You can think through it logically to figure out what you need to do here. You can also use your units. Anytime you have a problem like this, I've been teaching a lot about units, and that's really important and really helpful here. But before we do that, let's just think about it. We have a train. It's going at 34 miles per hour. That means that every hour it travels another 34 miles. So it's 34 miles, and then another hour goes by, it goes another 34 miles, and then another hour goes by, and another 34 miles, and so on. So each chunk of an hour is 34 miles that this train goes, okay? Now it says, how many hours does it take to go 110.5 miles? So you're trying to go this far, 110.5 miles. Let's say that's this far, 110.5 miles. But each hour, you go 34 miles an hour, which is somewhere around here, right? So 1 hour, here's 34 miles. Here's another 34 miles in that hour. Here's another 34 miles in that hour. Here's another 34 miles in that hour. So if we divide the 110.5 by the 34, which is 34 miles every hour, we see how many slices of 34 miles an hour we can fit in there, then that will be how many hours it takes. Because we said it's 34 miles per hour. So if we know it takes 1 hour to go this far, and then another hour to go this far, and another hour to go this far, and so on until we get to the 110.5, that many hours is how long it's going to take to do it. So that's why you have to divide. So what we're going to do is we're going to divide here. And another way to do that is using your units. If you're going 110.5 miles, okay, and here's my little unit thing that I'm going to use here. And you know that you're traveling, I'm going to write it over here, 34 miles per hour, okay? 34 miles per hour. That's what this is your speed here, okay? Now let's look at this if you weren't sure what to do. If you put 34 miles per hour, if you put it like this would get you nowhere because you have miles up here times miles over here, 110.5 times the 34 hour. You would have, the units wouldn't make any sense because you're trying to find out how many hours does it take to go this far. The units just simply don't work if you do that. So multiplying by 34 gets you nowhere because the units don't come to what you want to do. You want to know how many hours it takes, okay? But you can write the 34 miles per hour as 34 miles per hour, okay? You can write them when you're doing this technique here of units here. Anything that's coupled together like this, 34 miles per hour, you can flip it just like I've done. You can write it 34 miles per hour, which got us nowhere, or you can flip it over and say 34 miles per hour. You can read it upside down, top and bottom. Now, what happens when we do this is that because miles is on the top with miles on the bottom, they cancel. They just disappear, okay? So, because this is on top and this is on bottom, this is division here. Okay, anything on the top and anything on the bottom is divided by one another. So, by putting it this way, you know that you must divide by 34 because that is the only way that the units come out to hours. Okay, so you can always use your units to help you figure out what to do. So if you take 110.5 and you divide it by 34, the units will cancel so that you'll have hours left over, and hours is what you want. So if you're confused about do I multiply or do I divide these, it is very confusing sometimes. And if you can't think through it logically, sometimes it's good just to put the units up there and figure out how to write it down so that the unit comes out the way you want it. In this case, it's hours. Okay? So we have discovered that all we want to do is divide like this. We want to divide 110.5 divided by 34. So divided by 34 like this. And we know it's a decimal, so our decimal point goes right on top just like this. Okay? Now, how many times can 34 go into 1? Well, 0 times, so we're not going to write that down. How many times can 34 go into 11? Well, 0 times because 11 is too small. How many times can 34 go into 110? And the answer is 3. Okay? And I think you can convince yourself here because 34 times 3, 3 times 4 is 12, okay? And 3 times 3 is 9, plus 1 is 10. So you get 102 here. So by putting a 3 here, 3 times 34 is 102, which is pretty darn close to 110 without going over. So that's why that's the right answer there. Okay, that's why it goes in 3 times. Okay, so it's 102, and now we have to subtract. Okay, 110 minus 102, what does that come out to? Well, 0 minus 2, we're going to just subtract this column here. 0 minus 2, you can't really do it, so we're going to borrow. We're going to put a 1 there, and we're going to make this a 0 in the next column. Okay? 10 minus 2 gives you 8, because starting at 10, subtracting 2, 9, 8. We subtracted 2 more and got 8. And now that we've borrowed here, this is 0 minus 0, which gives us 0, and 1 minus 1 gives us 0, so we're done there. Okay? We're done. So 110 minus 102 gives us 8. And now you have to ask yourself, after you do this subtraction, the next thing you need to do is to drop down the next digit, is what we always do, which is 85. And now you have to ask yourself, how many times can 34 go into 85? Okay? And the answer is 2. Because if you take 34 and multiply it by 2, 2 times 4 is 8, and 2 times 3 is 6. Okay, which is 68. Okay, now if you took 34 and multiply by 3, because maybe you're going to try and see if you can put a 3 up here. We already did that before. 3 times 4 is 12, and then 3 times 3 is 9, plus 1 is 10, which gives you 102. That's too big, okay? So you cannot put 3. It doesn't go 3 times because that's too big. It only goes 2 times, okay? It only goes in 2 times, and even then, you have some leftover, okay? So 2 times 34 is 68, just like we said, and we do the subtraction here, okay? Now, we look at this column and begin to subtract 5 minus 8. You really can't do it, so you borrow, just like we talked about before. We make this a 15 and we make this a 7 because we're borrowing from the next column. Now, what's 15 minus 8? Starting at 15, 14, 13, 12, 11, 10, 9, 8, 7. Okay, so we took away 8. We got 7 left over. Now moving to the next column, since we borrowed, what is 7 minus 6? Well, that is just simply 1. Okay, that is just simply 1. Now, we always said, now we have something other than 0 left over, 17, okay? And we always said that after we do the subtraction, we must drop down the next digit, but there's no other digit to drop down. So we're going to make up a digit, we're going to put a 0 here, and we're going to drop this 0 down here. And we can do that all day long because, as I said before, if you have 3.2, that's the same as 3.20, that's the same as 3.200, that's the same as 3.2000. So you can add zeros after a decimal point as many times as you want. So we just put a 0 there and we dropped it down because you're not changing the problem at all. Okay? Now the question is, how many times can 34 go into 170? And the answer is going to be 5, because if you were to take 34, okay, and multiply by 5, what would you get? Okay, 5 times 4 is 20, so we put the 0 and carry the 2. Okay, now moving on, 5 times 3 is 15, plus 2 is 17, so 170. So you know that it goes exactly 5 times because when you multiply, you get 170. So you do the multiplication, you get the 170, and you subtract, and then you get 0. So you're done. You have a remainder of 0, and you're completely done. And the answer that you got to this problem was 3.25. And what were we shooting for? It's 3.25 hours. Okay? And just see if this makes sense. You have a train that's going 34 miles an hour, okay? 34 miles an hour, and it's going 110.5 miles. It kind of makes sense that if it's going 34 miles per hour, it's going to take a few hours to go 110 miles, and that's what we got here. So you just had to put the number down and begin dividing into each digit, multiply, subtract, drop down the next one, and do it exactly like that. Okay, the next problem says, a tree is 12.4 feet high. How many boxes stacked up does it take to reach the top of the tree if each box is 1.2 feet high? Okay, so you have a tree, it's 12.4 feet high, it's pretty high, and you have a bunch of boxes and they're 1.2 feet tall each, and you want to stack these boxes on top of each other, and so that you can reach the same height as the tree. So you want to find out how many boxes do you need. And this one isn't quite so obvious, but when you think about it, you know you need to divide here, because if you have a tree this tall, it's kind of the total amount of something, like I was trying to tell you before. The total amount, the total height of this tree is 12.4 feet high, and each box is 1.2 feet. So if you're going to see how many boxes you need to divide the height of this tree by the height of each box, and that'll tell you how many boxes you need. Okay? So you're dividing the height of this tree up into equal number of parts of boxes that are 1.2 feet high each. So you're going to have to divide, same as before, and so this one's a little bit different, but very important for you to know, because you have 12.4, that's the height of the tree, but you're now dividing it by 1.2. Now the difference here is that you're dividing a decimal by a decimal. Okay, so before we had a decimal under here and we just had a number out here. Now we have a decimal, and a lot of people get confused on what to do next. Well, it's very, 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 very simple what you do next. All you have to do when you have something like this is you move each decimal point over to the right one spot. Okay, and you can do that, and that's totally legal to do. So you'll have 12 over here, and then you'd have 124 on the inside. Okay. So what you do is you transform the problem. You don't like having a decimal here on the outside, so you just move it over one spot. But in order to make it legal, you have to move this other one over one spot too, and then the problem is the same. If you just move this one, then you've changed the problem. If you just move this one, you've changed the problem. But if you move this decimal point and you move this decimal point, both at the same number of spaces, which is what we've done here, the problem is exactly the same. And you're going to get the same answer. And so that's why you can do that. So now that we've done that, we don't have these ugly decimal points anywhere. We can do our division. Okay? We can do our division. So let's look at this. How many times does 12 go into 1? Well, that's 0 times. 1 is too small. So then we begin to look at the next digit. How many times can 12 go into 12? Well, that's 1, because 12 times 1 is 12. So we write it down. 12 times 1 is 12. And we subtract. Okay? 12 minus 12 gives us 0, and after we've done the subtraction, we drop down to 4. Okay? So now we begin to look and say, well, how many times can 12 go into 4? Well, we know that's 0. We can't go in at all, so we put a 0 up there. So 0 times 12 gives us 0, and we subtract, and we have 4 down here, and now we want to drop down our next digit, because you see we're not done dividing. We've still got this 4 hanging out, and we still need to keep dividing until we get to the end. But we've run out of digits to drop down. Well, I told you before, you can put a decimal point in here, and you can put another digit afterwards. That's totally okay to do, because, like I've said, 5 is the same as 5.2. I'm sorry. 5 is the same as 5.0, which is the same as 5.00, which is the same as 5.000. These zeros after a decimal don't change the number. They never have, and they never will. So you can add a dot 0 here, and I'm going to go ahead and write this 0 as kind of a dotted 0 just to remind you that we added that one. Okay? You have to add it after a decimal point. And because we put a decimal point in here, we're doing a division problem, so we need to put our decimal point immediately above it. Okay? So now that we've added this 0, we can drop down and put a 0 here. And now the next question is, how many times can 12 go into 40? Well, it's going to go 3 times, because 12 times 1 is 3, 12 times 2 is 24, and 12 times 3 is 36, which is pretty close to 40, and 12 times 4 just blows it out of the water. That's 48. So it's going to be 3, because 3 times 12 is 36. We're trying to get as close as we can to the number without going over it. Okay, what is 40 minus 36? Well, we can work in this column here. 0 minus 6 you can't really do. So you have to borrow. You have to make that a 10 and change that into a 3, because we're borrowing. Okay? So 10 minus 6 is going to be, starting at 10, 9, 8, 7, 6, 5, 4. We subtracted 6, and we got 4. And in this column, 3 minus 3 is 0, so we don't need to put that down. And it makes sense. I mean, 40 minus 36 is 4. Okay? So we have our 4 here. And again, we have another thing here, but we would like to continue dividing here, but what do? We ran out of digits. We can add another 0, okay, and we can drop it down, put another 0. Well, now look what's happening. Okay, if we keep adding zeros, we'll keep asking ourselves how many times can 12 go into 40, and it'll be 3 times, just like it was before. And then each time we'll multiply by 12 and we'll get 36. Okay, and each time we'll subtract, we'll get 4. And then each time we'll get down to 4 and we'll say, well, what do we do next? And each time we'll add a 0, and each time we'll drop the 0 down and we'll get another 40. And we'll keep going over and over and over and over and over, and we'll never stop. Okay, so this 3 here, the answer to this problem is 10.333333 on forever. The 3's go on forever and they never stop, because when you keep dividing here, you're always going to get another 3 and another 40 and another 3 and another 40 and on and on. So the way you write this is 10.3 with a little line over it. That just means that the 3 goes on and on and on forever. So here's where we stand. A tree is 12.4 feet tall and the boxes are 1.2 feet high. How many boxes you need? Well, you need 10.333333 boxes, and you're not going to get 0.3 of a box. You know, you're not going to get a box with 0.3 of a box. Okay, so really and truly, in order to reach the top of the tree, you really need 11 boxes. Okay, because you cannot go to the store and buy 0.3 of a box. So you could get all 10 of these boxes, but you still need 0.3333 more. And where are you going to get that? You can't buy that from the store. So if you were going to figure out how many boxes to buy, you would need to go buy 11 boxes, stack them up, and the 11 boxes is going to be a little bit taller than the tree, just a little bit, because it only actually took 10.33333 boxes. So your actual height is going to be a little bit higher than the tree because of that. Okay, so that was an interesting problem because you had a decimal divided by another decimal, and in that case you can move those decimal points together to the right to make the problem easier. Okay. Now our final problem in this section says you operate a lemonade stand and you want to earn $20 on Saturday. That's your big day of the week. You want to earn $20. Each lemonade costs $1.25. How many do you need to sell? Okay, that's the question. How many do you need to sell? So it's the same formula. You're given the total amount of something. In this case, it's $20. You want to earn $20. You're told how much each lemonade costs, $1.25, and you're asked how many do you need to sell. So if this represents the $20 that you want to make, and this represents how much each costs, you want to divide them in there to see how many lemonades you need to sell in order to make up that $20. Okay? So you're dividing the $20 up among the number of cups of lemonade that you would need. That's how many you need to sell. So you're going to be dividing, okay? So you're going to try to make $20, and you're trying to divide $1.25 into there, okay? Now, the first thing you notice is you have a decimal here and you have a decimal here, and we never like to see a decimal in both places. So what we can do is we can just move this decimal over 2 times to the end, and we can move this decimal over 2 times to the end, okay? So we'll have, it makes it 125 divided into 2,000, okay? So we've changed nothing. The answer to the problem, which will be up here, will be exactly the same as it is here. It's just that I don't like having these decimals here in both places, on the outside and on the inside. So I scoot that decimal point to the right, and in order to keep the problem the same, I have to scoot this one to the right too. So that's why I did it like this. Okay? So then you can begin to start dividing. How many times will 125 go into 2? Well, the answer is 0. 2 is just simply too small. How many times will it go into 20? Again, it's not going to go in at all. How many times can 125 go into 200? I think you'll all agree it goes 1 time. Okay, because if you try to go 2 times, that's going to be 250. That's too big. So 1 times 125 is 125, and then you subtract. Okay, you subtract. So in order to do this 200 minus 125, you're going to need to do some borrowing. This is going to become a 10, okay? And I'm going to borrow that from the next column, but the next column is a 0, so I need to make him a 10. And in order to make him a 10, I need to make him a 1. So I'm borrowing to make this middle one a 10, but don't forget, I need to borrow from him, making him a 9. Okay? So what I've done here is, this guy we borrowed to make him a 10. We borrowed from the next column, So in order to borrow from the next column, I had to make him a 10 and then make him a 9. And in order to do that, I had to borrow from the guy in front of him. So I continued borrowing from the left. Okay? In order to borrow from him, I had to make him a 10 first, and then I borrowed from him, making him a 9. Okay? So here, 10 minus 5 gives you 5. Okay? 10 minus 5 gives you 5. And then in this middle column, 9 minus 2 gives you 7. Okay? So we've finished with our subtraction because 1 minus 1 gives you 0, so we're done. We've done our subtraction. And now just like on all of these problems, we drop down the next digit. So now we're at 750. Okay? How many times will 125 go into 750? Well, another way of saying that is 125 times what number will give you 750? And the answer is going to be 6, because if you take 125 times 6 and multiply it, 6 times 5 is 30, so I carry the 3. Now moving on, 6 times 2 is 12, plus 3 is 13, 14, 15. So I'll put the 5, carry the 1 because it's 15. And then 6 times 1 is 6, plus 1 is 7, so it's 750. So it goes exactly 6 times. 6 times 125 is 750. And then when I subtract these two, 750 minus 750 gives you 0. So you stop. You're completely finished. You're done dividing everything in this problem. And the answer is you need to sell 16 lemonades. Okay, you need to sell 16 lemonades, okay? Because you had $20 you're trying to make. Each one was $1.25, okay? And when you do this division, you just shift the decimal points in both places, and you begin just looking at it. Going into the 200 was one time, gave us 75 left over, dropped down to 0, okay? And then 125 went into the 750 6 times, and when you did this, it gave you a remainder of 0. So that was it. You stop. You've done your division, and it's 16 lemonades. So in this section, we have covered a lot of ground. We've done word problems that involve division of decimals, which usually involves giving you the total amount of something and then how much of something costs individually, like the 5 DVDs you have, or each lemonade is $1.25. How many do you need to sell or to buy or whatever? So usually you're given the total amount and then how much something is, and then you're trying to see how many of something do you need to buy or to do or whatever it is. And so you're going to need to divide. You're taking that total amount, you're dividing by how much, in this case, how much each lemonade was, to tell you how many lemonades you need to buy. So if you just work some problems, you understand what you're trying to do and not guess, okay? And then also just see if it makes sense. It makes sense that you would need to sell about 16 lemonades to give you $20 there, because each lemonade costs just a little bit more than $1. So if each lemonade cost $1 exactly, you would only make $16. Okay, so that's almost 20 by itself. But each lemonade costs a little bit more than $1. So this kind of makes sense. This answer makes sense. So with some practice, I think you'll understand how to do word problems involving division with decimals.